This is the key to topic 18, part A. And in topic 18, you're dealing with transformations. So number one, you're given that f of x is x squared and g of x is x squared minus 2. And it says, which of the following transformations can be performed with f of x? So remember, f of x equal x squared is your parent function to obtain the graph of g of x. All right, so just kind of remember what it just said. So number one, f of x, which equals x squared, that's called your parent function. Parent function. Sometimes a textbook will call it the basic function. So keep that in mind. So the terminology it means the same thing with reference to x squared. So your parent function is x squared. Sometimes they'll say the basic function is x squared. What you want to do though is you want to graph, or you want to talk about the transformation of g of x, which is x squared minus 2. All right, so x squared minus 2. Now, before we go on, let me just kind of remind you what the graph of f of x looks like. So sometimes in your mind, to help you with these problems with transformations, it helps to remember what the graph of your basic function or your parent function looks like. So that's the graph of the function x squared, f of x equal x squared. So that's what that looks like, okay? Now, what I want to do though is I want to graph g of x, which is x squared, your basic function, minus 2. So what I want you to notice is this. If I rewrite g of x, that function that I want to talk about, and I want you to notice that this part here, if I cover up the subtract 2, that is f of x, right? This part here. So x is x squared, I'm sorry, is f of x. So do y'all agree? Do y'all agree that this, I can think of this as your basic function subtract 2, right? Your basic function, your parent function subtract 2. So g of x, all g of x tells you to do is to take your parent function and subtract 2 from it. Subtract 2. Now remember guys, f of x means the same thing as y, right? So if I look, remember the same thing as y. So if I look at this point right here, and let me go ahead and label that point. So if I label, well, it's a thick mark, so let me go ahead and do it this way. So if I label this point right here, that is the point 39, okay? That's the point 39. If I do what this says I take the y value of this point and I subtract 2 from it. That's what that says. So 9 minus 2 is 7, right? So then this becomes 3, 7. So 3, 7 is here. Okay, so that's the point 3, 7. And if I look at this point here, see this right here is the point 2, 4. See, that's 2, 4. And if I subtract 2 from that y coordinate, I get 4 minus 2 is 2, so I get 2, 2. So 2, 2 is here. And if I look at this point here, which is 0, 0, this point here, which is 0, 0, and I take that y coordinate and I subtract 2 from it, then 0 subtract 2 is a negative 2. So this becomes 0, negative 2. And then I keep doing the same thing on the other side. What I want you to notice is this. Do you see what's happening? That every point on the basic function is being brought down 2 units. So 1, 2, 1, 2, 1, 2, 1, 2, 1, 2, 1, 2. See that? That's the idea there. So every point on my parent function is being shifted vertically down 2. So this is the graph here. This is the graph of g of x, which is x squared minus 2. So, whenever the numbers on the outside of your parent function, see this is the parent function, right? X squared. Whenever the numbers on the outside, you're shifting it either vertically up or vertically down. So since I'm subtracting 2, it's being shifted vertically down 2. All right. So so for number 1, where it says if your parent function is x squared and you want to grab g of x, which is your parent function subtract 2, which of the following transformations can be performed with your parent function to get g of x? Then remember that's where we shifted it down to, so it should be vertically down 2 units. So that's a D. So the answer is D for that one. Okay? All right, let's look at number 2. Number 2, the parent function this time is the absolute value function. So let me remind you what that looks like. So you graphed these last semester, and you also graphed these in a previous lesson in this course. So there's the absolute value function. All right. Now what I want to do here in number 2, let me go ahead and write this down. So number 2, you have your parent function, which is the absolute value of x. So that's your parent function. Sometimes remember it's called the basic function. And you want to graph, or you want to talk about the transformation of g of x, which is the absolute value of x plus 3 minus 2. All right, so that's the value of x plus 3 minus 2. Now, one of the things that you learned in your lessons was that notice that if the number, if you're performing an operation on the inside of the function like I am here, see where I have x plus 3? That is a horizontal transformation. The number on the outside, if the number's on the outside like this one is, then that's a vertical transformation. So I want you to notice that I have a horizontal transformation, and I have a vertical transformation. So it's very important that you know which one's a horizontal, which one's the vertical. The vertical transformation is always the easiest to understand, and you saw it here. So you're taking that y value and you're subtracting 2, so you bring it down 2. If this was plus 2, you'd be shifting it up 2. So the vertical is always the easiest. The horizontal is not as easy. So to think about the horizontal, you got to think about the opposite of what you see here. So I'm adding 3, so think the opposite. The opposite would be to subtract 3. So basically, you're going to be shifting the absolute value function, the parent function, to the left 3 units. You need to write this as this. So you would write it as, when talking about transformations, you would write it as x minus a negative 3 minus 2. So this would be your horizontal transformation, and this would be your vertical transformation. Okay? All right, so it's very important you always remember it's x. When it's on the inside of the parent function, it's always x minus, and then so x plus 3 will be x minus a negative 3. So your horizontal transformation is a negative 3. So since it's negative, you're going to do this. You're going to go to the all right, so since it's negative, see negative 3, always do the horizontal first, always do the vertical last. So you're going to go to the left 3 units. So here's what's happening. So you go 1, 2, 3, take this point here, 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 go 1, 2, 3. The vertex here, you're going to go 1, 2, 3 to the left as well. 1, 2, 3. And then you get, oh, and by the way, so this right here, just to let you know, so this right here, what I've graphed here, this is the function y equal the absolute value of x plus 3. That's what this is. So many students get this confused. They see that plus 3 and they want to shift it to the right. It's not. Whenever you deal with a horizontal transformation, always think always think the opposite of what you see. Okay, and then finally, what you want to do is you want to subtract 2 now. So you're going to take that graph right here, and since I'm subtracting 2, since that negative 2 is on the outside, that's your vertical. So you can move it down 2 units. So then I'm going to get, so every point on here, I'm going to shift it down 2 units. 1, 2, 1, 2, 1, 2, 1, 2, and so on. And so this right here, by the way, just to let you know, the red graph is the graph g of x. So g of x equal the absolute value of x plus 3 minus 2. Okay? But that's what you go through. So you take your parent function, you can do the horizontal first, so you go to the left 3 units, so you move every point to the left 3 units, and then once you do that, then you can do the vertical transformation, then you're going to move that down 2 units. And that red one would be your final graph. So in terms of our answer, then this is what you're going to say. You're going to say, all right, so I'm going to do the horizontal first. So I'm going to go to the left 3 units, and then I'm going to do the vertical next. I'm going to go down 2 units. So we need to find the one that says horizontally to the left and then vertically down 2 units. So that's going to be, it looks like letter B. Shift the graph horizontally to the left 3 units and then down 2 units. So that's letter B. Okay? All right, let's look at number 3. So number 3, this is what we have for number 3. So we have a square root function, and the square root function looks like this. So if you go back to your lessons, you remember how we graphed this. So that's the basic function. That's the parent function. Okay, now what I want to do in this one, though, is I have a negative in front of that square root, and then I have that plus 2 on the outside. So let me go ahead and write this out. So your parent function in number 3 is the square root function. So there's your parent function. That's the parent function, or the basic function. And you want to look at, so you want to look at the transformation of g of x, which is equal to negative square root of 3, square root of x, negative square root of x plus 2. Okay? Now remember, always do the vertical transformation last. So that's my vertical transformation. Now, inside my parent function, see that's x, x stays the same. So there's no horizontal transformation. So I want you to notice there's no horizontal transformation. There's none. See, square root of x, square root of x. It was different than this one. See, absolute value of x plus 3. See, that was different, okay? But there's a negative out in front. So you got to remember that when the negative's out in front of that parent function like this, when the negative's out in front, then that's a reflection about the x-axis. Reflection about the x-axis. Okay, the x-axis, reflection about the x-axis. All right, so there are 2 transformations you're going to do here. You're going to do the reflection about the x-axis first, and then you're going to shift it up 2 units since it's positive. I'm going to shift it up 2 units. All right, so here's what you're going to have. So I would do this with a green marker. So every point is shifted about the x-axis. So see this point right here, just to let you know, this point here, the point 1, 1 right here. When I shift it about the x-axis, it becomes a point 1, negative 1. See right here? So that's going to be 1, negative 1. See this point here? That's 4, 2. 4, 2. When I shift it about the x-axis, see how it's 2 units above the x-axis? I go 2 units below. So that becomes the point, the x-coordinate stays the same. The y-coordinates become opposites. So that becomes 4, negative 2. And you see this point here? That's 9, 3. 9, 3 right here. So that's 3 units above the x-axis. So I go 3 units below the x-axis. So here's that idea of reflecting about the x-axis. So I go 3 units below, 1, 2, 3, like this. So that becomes the point 9, negative 3. And don't forget the point 0, 0 stays 0, 0. Kind of makes sense because the opposite of 0 is still 0, right? It's on the x-axis. And so this right here, this right here, this is y equal negative square root of x. Okay? And it makes sense because all this says, you remember right here, if I kind of cover some stuff up, see this right here? So this right here is f of x. So right here, let me kind of do this. All right, so this right here is f of x, which is the same thing as y. So this says whatever my y value is, I take the opposite of it. See, negative y, okay? So if y is 1, the opposite of 1 becomes negative 1. If y is 2, the opposite of y becomes negative 2. If y is 3, the opposite of y becomes negative 3. So hence, that's why we say this is a reflection about the x-axis, because the y values become opposites. All right, now, what we're going to do next is, now we've got to shift it up 2 units. So that's going to be my red graph. So I'm going to shift it up 2 units, and when I shift it up 2 units, I get, I see right here, so I'm going to get 1, 2, like this. Oh, and don't forget the vertex. I'm sorry, the beginning point. 1, 2, right here. 1, 2, 1, 2. This becomes 1, 2, and this right here becomes shifted up 2 units. 1, 2, and so the red graph is the function g of x, which is negative square root of x plus 2. That's the red graph. Okay? All right, so in terms of our answer, here's what you're going to write. You're going to say fill in the blanks, and then it says use the following to complete the blanks. So letter A is horizontally left, letter B is horizontally right, letter C is vertically up, letter D is vertically down. E is reflect about the x-axis, F is reflect about the y-axis, and then it says just use the appropriate letters. So use letters in here. So to obtain the graph of g of x, remember this is your parent function, we would reflect, you do the reflection first. So we would reflect we would reflect the graph of f of x. Now remember that the reflection is a reflection about the x-axis, so that's going to be x-axis, that's going to be E. So E is going to go here, reflect the graph of f of x, reflect about the x-axis, and then we would shift it vertically up 2 units. So that's going to be letter C. Letter C. All right? So the answer is E and C for that one. Okay, so that is the key. That is the key to worksheet part A, topic 18.